Okay, today we will continue on chapter number 2. Okay, so before this, we already covered about the database. Okay, if you look, you already have your reference book. Okay, so if you have your book, okay, during this class, you can open on page 24. Okay, 24, 25. So that related to the cadastral database. Okay, so related to the cadastral database, start with the digital cadastral database and then national digital cadastral database. Okay, so for today we will continue on about the cadastral coordinate system. Okay, and then the global navigation satellite system. Okay, that relate in the cadastral environment. Okay, next we will look into the type of boundary mark. Okay, so type of boundary mark that will be used in order to differentiate between your lot with your beside of your lot. Okay, your neighbor lot. Okay, so that will separate. So that will be as your marking. Okay, for the land lot. Okay, so if you look on page 30, on page 30, okay, so it's about the cadastral classic geodetic datum. Okay, classic geodetic datum. Okay. Okay, so this geodetic datum, it will relate with the geodetic datum. So this one you will learn in the geodesy semester 4. Okay, but I need to explain about this because when you want to mark, when you want to prepare the mapping, okay, the mapping plan. Okay, so you need to set your coordinate into the Cassini, Cassini Solner. Before this, before the GDM 1000, okay, so all the mapping referring to the Cassini Solner. But when have the GDM 2000, so nowadays you will need to set to the Cassini geocentric. Okay, so based on the historically, okay, the triangulation system of Malaysia consists of two. Okay, so in Peninsular Malaysia, you will focus on the Malayan Revised Triangulation (MRT). Okay, and then another one, Sabah Sarawak, covered by the Borneo Triangulation. Okay, so if you look to the Malayan Revised Triangulation, okay, the definition is a local geodetic reference for Peninsular Malaysia that replaced the Repsol triangulation and known as the Malayan Revised Triangulation (MRT) on 1948. Okay, the early geodetic infrastructure established for the basis of surveying and mapping in Peninsular Malaysia. Peninsular Malaysia, known as a primary or Repsol triangulation network. Okay, so so you will look, okay, the triangulation that cover on the center of the Peninsular Malaysia. Next, Japan obtained the initial position of a point in Taiping in 1885. Okay, by directly observing the stars, and the triangulation scheme in Peninsular Malaysia was completed in 1916. Okay. So this one, the classic geodetic datum. Okay, we call as a MRT 48. Okay, so this is the first point. Okay, by observing to the star. Okay, so it locate the point in at the Taiping. Okay, and then from the Taiping, so it will create the triangulation and cover to all the Peninsular Malaysia. Okay, but only focus on the center. Okay, if you look here, only focus on the into the center. Okay, since 1948, okay, MRT has been used for geodetic mapping, cadastral, and other survey activities in Peninsular Malaysia, known as MRT 48, followed by a lengthy process of additional measurement and recomputation until 1968, then referred to as MRT 68. Okay, so that's why, okay, sorry. Okay, so that's why you will see the word MRT 48 and then MRT 68. Okay, so because of they have a computation, okay, so that's why it changed to the MRT 68. Okay, so this network refer to the modified average. Okay, modified average ellipsoid as reference ellipsoid and curtile as origin. Okay, what is the ellipsoid? What is the origin? Origin is a center, and then ellipsoid is a one of the surface. Okay, that you will use this term. Okay, in the geodesy. Okay, in the geodesy subject semester 4. Okay, so you will see what is the ellipsoid. Okay, so that is a one of the surface. Okay. Okay, so the triangulation. Okay, so the triangulation example here, example in this slide. Okay, focus on the triangulation station at Negeri Sembilan. Okay, so from this data they have a station name. Okay, and then geographical position, like in terms of the latitude and longitude. Okay, and then they have in the RSO, rectified screw automorphic. Okay, and then they have a state Cassini coordinate. Okay, so all these in change, in change. Okay, nowadays you will see the unit in meter. Okay, so on the previous they will use change. Okay, dalam unit runtime. Okay, and then latitude and longitude. Okay, so this is the standard and the standard unit. Okay, you have a degree, minute, and second. Okay, then this below example of the plan, the plan that cover show the triangulation at Negeri Sembilan, Johor, and then part of Kelantan. Okay, don't feel difficulty to understand because I only will touch about the overview. Okay, because about the okay about in a deep learning, okay, you will learn in the semester 4 geodesy. Okay, I only want to relate with the geodetic datum term, okay, in the cadastral. Okay, next, Brunel triangulation 1968, or we call as a BT68. Okay, so this geodetic network in Sabah Sarawak, okay, cover for the Sabah Sarawak. This triangulation resulted from the readjustment of the primary control of East Malaysia, Sabah, Sarawak, and Brunei, made by the Directorate of Overseas Survey, United Kingdom. Okay, so you will look the triangulation that cover. Okay, also only the center, the center of Sarawak, and then for Sabah, okay, it will not cover overall. Okay. Okay, so that cover for the classic classic geodetic datum. But now, when enter to the modern geodetic datum, modern geodetic datum start 1984. Okay, so what inside the modern geodetic datum? Okay, prior to the introduction of GPS technology, national mapping and cadastral in Malaysia relate to the old system of the MRT 68 in Peninsula and the BT 68 in Sabah Sarawak. Okay, so start from 1994. Okay, the introduction of a GPS technology. Okay, so that's why during that time, okay, the survey department and then the surveyor in Malaysia start to use the GNSS. Okay. But during that time, that is so expensive, okay, compared to the nowadays. This traditional survey control system were referred to a non-geocentric datum, okay, based on the modified Everest ellipsoid. Okay, both fit well regionally but not globally. Okay, so it means that okay, during this time, okay, when you use MRT 68, okay, only it will accurate, okay, on the certain area, okay, not cover the global area. Okay, then we go to the so means the introduction to the modern geodetic datum. Okay, start 1994. Okay, then needs toward geocentric datum. Okay, why needs towards to geocentric datum? Okay, why use satellite positioning system? Okay, so um, okay, why from the classic, okay, MRT 68, and then want to change to the GTM 2000? Okay, because start use the satellite positioning system, okay, in all area. And then existing datum incompatible. Okay, so existing datum is incompatible. Okay, so this one referring to the local. It will only refer to the local, so not global. And then adopting a global unified datum for Peninsula Malaysia, Sabah and Sarawak. Okay, by having a GDM 2000, so it will focus, okay, on the global. Okay, you will cover for Peninsula Malaysia, Sabah and Sarawak. And then in line with the international recommendation. Okay, so means the control, okay, that create during the GTM 2000, okay, established. So it will tie, okay, it will tie with the national control point. Okay, so later you will see, okay, what is the national control point. Okay, in the modern geodetic datum, okay, so modern geodetic datum start since early 90, okay, so you will have introduced to the two GPS network, okay, so this one we call as a Peninsula Malaysia Geodetic Scientific Network, okay, 1994, and then East Malaysia Geodetic Scientific Network EMGSNN 97. Okay, all this you will see, you will see during example, you use a software and software to convert the coordinate. You want to convert the in term of the datum. Okay, so you will see the PMGSN 94. Okay, so during that time you will relate with what you have learned in the class. Okay, in this class. Okay, when the PMGSN 94 already being used in Malaysia. These two GPS network known as a passive GPS network. Okay, so during this class, I want to I explain, okay, start from the classic and then modern until okay, you will introduce with the GDM 2000. Okay, so this one example the place of a PMGSN. Okay, so PMGSN. Okay, so this one of the location, and one of the location. So this have been conducted by the student. Okay, during that time. Okay, so this one you will look the monument like this. Okay, so this monument you will look like uh, have you looked like this monument class?
Yes, sir.
Yes, sir.
Have you looked
Yes.
the monument maybe in UITM that you look similar to this monument,
No, sir.
or in engineering? Have you introduced with the leveling? Not yet.
No, no, sir.
Okay. So if you
Not
learn
yet, sir.
you learn engineering chapter 2 leveling, okay, or you walk surrounding in UITM or at the outside, okay, so maybe you will look the monument like this, okay, but you don't confuse this one used for the control point for the PMGSN 94. Okay, so this one already write down as a station GPS. Okay, station GPS, and then prepared by Jabatan Ukur dan Pemetaan. Okay, so this one similar, similar. If you look the monument similar to the benchmark. Okay, in the engineering we call as a benchmark. Okay, so you will use the center of this monument, okay, as a reference to conduct your leveling. Okay, but this one for GPS, for GPS. Okay, so this is a control point for the PMGSN 94. Okay, so you will don't have the value. Okay, all the value same goes to the benchmark. If you learn in engineering, you need to refer to the survey department. Okay, so you look during 1994. Okay, they already established a case to cover surrounding the peninsula. Okay, the distribution already distribute well. Okay, surrounding of the area. Okay, then active GPS network and realization of geocentric datum of Malaysia. Okay, that we call as a GDM 2000. Okay, GDM 1000 new Earth Center coordinate datum for Malaysia to replace the old datum. Okay, so this is a new datum. Okay, a new datum we call as a GDM 1000, and then on the previous datum, okay, you have MRT 48 and BT 68. Okay, so if you have the data, okay, the data that you required, you required to have in the GDM 1000, but the data referring to the datum MRT 68. Okay, so your task, you as a surveyor, you need to know, okay, if you want to convert from MRT 48 to GDM 2000, so that we call as a datum transformation. Okay, so you will have a datum transformation on page 34 and 34 if you look to your reference book. Okay, begin firstly by the establishment of the zero order network of permanent GPS station known as the Malaysia Active GPS System Station, MES. Okay, or sometimes we will call as a MES station. Okay, connect to the 18 MES station with the 11 global permanent GPS network, international GPS service station. Okay, called as a IGS in ITRF 2000 epoch 1997 were used as a fiducial points in the processing to obtain the MES set of station coordinate. Okay, so in order you look to the mass station, okay, they have a mass station surrounding Peninsula Malaysia, and then all the mass station will tie to the global permanent GPS network, okay, called as a IGS. Okay, IGS referring to the ITRF 2000, okay, epoch 1987. So epoch means the calculation have been made, okay, during 1997. Okay, in order to obtain the uh, coordinate station, okay, for the mass station. Okay, so if you look here, this one, the IGS station, okay, that cover, okay, that cover in surrounding area, global. Okay, and then we have a 17 mass station, okay, mass station that cover in Peninsula and Sabah Sarawak. Okay, and then one of that, okay, we have in Arau, okay, where is a mass station in Arau, okay. So meaning from this IGS station, okay, so each of these mass station, okay, will tie, will connecting to the IGS station in order to calculate, to get the coordinate of each point of Arau, Ipoh, example here, Kuantan, okay, UTM, Segamat, okay, and the others, okay. So that coordinate refer to the IGS station. Okay, so this example of the MAS, okay, we call as a Malaysia Active GPS System. The establishment of the MAS in 1999 has provided the impetus for the adoption of the geocentric datum in all the geodetic activities. Okay, by implementing the MAS, Japan will continuously record carrier phase and sudden range measurement from all GNSS satellite available. Okay, so carrier phase, student range measurement. So this one relate with the GPS, GPS, we call as or in the geodesy subject. Okay, the network has been replaced with the MATK-net station. Okay, so previously, okay, so you already know about the MAS station, and then now the network has been replaced by the MATK-net station. Okay, so that is a current, current. Okay, so back to the geocentric datum of Malaysia, GDM 2000. So as you know, this is a new coordinate system, okay, adoption of geocentric datum and RTRF 2000. Datum unification between East and West closely coincident with the WGS 84 system. Okay, so dia menghampiri dengan datum. Okay, another datum we call as a WGS 84. So that is a okay, global datum. Okay, previously when you use a GPS, okay, so you can use a datum refer to the WG84. Okay, so meaning the GDM 1000, okay, almost closely coincident with the WGS84. Implementation of geocentric datum for mapping and cadastral surveying. Okay, so why you need to have a datum? Okay, so from a datum, you know, as a you have a globe example. You have a globe. Okay, so from the globe, okay, and then you want to map. You want to map to prepare for the engineering, engineering work. Okay, and then you want to plot for the cadastral plan. Okay, so that you will relate with the projection. Okay, so you will relate with the projection, okay, from the datum, and then it will change to the projection, example RSO, and then or Cassini geocentric. Okay, so later you will understand. Okay, for a while you just need to know about the term. Okay, for the ellipsoid, it will refer to the Geodetic Reference System 80, GRS80. Okay, if you on the previous, MRT 68, it will refer to the ellipsoid. We call as a modified Everest. And then officially launched nationwide on 26 August 2003. Okay, so already launched, already used, start 2003. Okay, if you look to this image, okay, so this is a modified Everest. Okay, and then you have the GRS80 ellipsoid. Okay, so this one the Malaysia. Okay, example, this one the Malaysia. Okay, and then if you look, the modified Everest, will regionally, fits to Malaysia. Okay, but when you look into the GRS80 ellipsoid, okay, it globally, fits to all the place. Okay, so that's why they have changed to the GDM 2000. Okay, next we go to the implication of GDM 2000. Okay, in term of technical, okay, so this is you need to know about the flow. So from old to the new datum, okay, on the left, you will have a flow. A flow example, if previously when you use a GPS instrument, okay, semester 4 you will introduce with that instrument. Okay, so you will know. You will start use datum WGS84. Okay, so okay, you will start use from the WGS84. Okay, then from WGS84 you need to change to the MRT 48. Okay, Malayan Revised Triangulation. Okay, from here it will have a calculation, okay, to transform from WGS to MRT. So they have a 7 parameter that need to be used, okay, to change it. Okay, I don't want to touch about the parameter because that is not related to the cadastral. Okay, the important things that related about this flow, and then from old to new datum here. Okay, so from MRT 48, okay, so you need this one, we categorize as a datum. Okay, then you have a projection change to the RSO old, MRSO. Okay, sometimes you will call as a MRSO. Okay, and then this MRSO will use in the engineering work. Okay, so it will cover for the example Peninsula Malaysia. Okay, when you want to focus on the state, so meaning you carry out the cadastral work. Okay, so that you need to change from MRSO to the Cassini-Soldner. Okay, so this another projection. Okay, so focus on state. Okay, for purpose of the cadastral survey. Okay, but now GDM 2000. Okay, GDM 2000. From GDM 1000, a new datum, you can change directly to the RSO geocentric. Okay, for the mapping. Okay, and then you want to apply in the cadastral work. Okay, so you need to change to the Cassini geocentric. Okay, example, if you have Cassini Solner, you have old Cassini. Okay, and then you required to prepare the data, okay, in the Cassini geocentric. Okay, how you want to change? Okay, how you want to change? Okay, This is important. From old to new datum, you need to know about this flow. Okay, from that, after this, you will know how you want to change. Okay, from Cassini old to a new Cassini. Okay, example here, we go first to the datum transformation. Okay, example datum transformation from WGS84 or MRT and then to GDM 2000. Okay, so example here, if you have the data, okay, in longitude, latitude, and height, okay, then you want to have a conversion, okay, to the Cartesian coordinate, okay, x, y, and z. Okay, so this one you need to perform the coordinate conversion. Okay, coordinate conversion. So coordinate conversion, you can see page 30. Okay, page 30. Okay, so there is a I explained about the coordinate conversion. Then for the datum transformation, okay, datum transformation means from example here MRT 68, you want to change to the GDM 2000. Okay, or from PMGSN 84 or WGS 84, you want to change to the GDM 2000. Okay, so this is the flow and the flow that you want to change. Okay, on the right here, so this one from GDM 2000 to the BT 68. Okay, so this one using the 7 parameter we call as a datum transformation. Okay, next projection RSO for topographical mapping. Okay, when I talk about the topographical mapping, so this one relate to the engineering work. Okay, you have an engineering subject semester this semester 150. Okay, so that you will apply. You will apply in order you want to map the data. Okay, so you need to set your coordinate into the RSO geocentric. Okay, so from the GDM 2000, okay, GDM 2000, you can directly change to the RSO. Okay, so you can directly change to the RSO. Okay, but if the previous, okay, if you have the GDM 1000, first you need to convert to the MRT 68, and then from MRT you need to change to the RSO. Okay, so that is a flow that you need to understand. Okay, so at least you know about the datum transformation and then map projection. Okay, other than that, you have coordinate conversion here. Okay. Okay, for the Cassini, projection to Cassini-Solner in cadastral mapping. Okay, so from GDM 2000, okay, from GDM 2000, so you can change directly to the Cassini-Solner. So this Cassini-Solner we call as a Cassini geocentric. But if you require to change to the old Cassini, okay, so from GDM 2000, you need to have a 7 parameter, okay, apply the datum transformation, okay, change to the MRT 68. From the MRT 68, then you change to the RSO. From RSO, you change to the Cassini-Solner old. Okay, class, until here, are you okay? Okay, at least you can identify what is the datum. Okay, datum for the coordinate system that will be used in the cadastral. and then you can identify what I call about the map projection, and then the coordinate conversion. Okay, and then the coordinate will be used in the cadastral work. Okay, so that refer to the Cassini Solner. Okay, you have a Cassini old, and then now you have a Cassini geocentric. Okay. Okay, next. Okay, about now about the Malaysia real-time kinematic GPS network. Okay, so this one in your book. Okay, page 35. Okay, page 35. Okay. So a network of real-time. Okay, a network of real-time kinematic network of 17.8 permanent GNSS satellite tracking station, 50 station in Peninsular Malaysia, and 28 station in Sabah Sarawak. Okay, so this one known as MyRTKNet Malaysia Real-Time Kinematic GPS Network. Okay, began collecting data since 2003 and the main source of GDM 2000 coordinate dissemination. Okay, so this is the distribution, the distribution of a MyRTKNet station, okay, in Peninsula and Sabah Sarawak. Okay, so as the name Malaysia Real Time Kinematic GPS Network. Okay. Okay, so this is the example of the MyRTKNet control station. Okay, so they have on top of the building. Okay, on the flat area. Okay, so I think all of you know where is the location of this monument. Have you familiar with this picture?
No, sir.
Okay, so if you walk surrounding in UiTM Arau, okay, I think the college for ladies called Kesinai, and in front of the Kesinai you have a cafeteria, if I'm not mistaken. Okay, so opposite of that cafeteria, okay, you have a flat area. So this is they have a one monument, okay, control station. We call it a MyRTKNet station. So this control station will be maintained by the survey department. Okay, so the staff JUPEM will enter to the UiTM, and then they will check, okay, about whether the control station okay or not. Okay, so they will check. So meaning the staff JUPEM will enter to the UiTM because the one of the control station, okay, located in UiTM Arau. Okay, objective of MyRTKNet, geodetic infrastructure for GNSS real-time positioning, reference frame and coordinate system, GDM 2000, for monitoring of tectonic movement, okay, and then geodynamic study. Okay, so this one in terms of the plate movement, about the earth, okay, on the underground. Okay, so that's why they prepare all this control station. Okay, if we see, okay, in northern area you have in Arau, okay, and then you have Langkawi, okay, and then Toka in Kedah, and then UUM. Okay, so this example, if you work, okay, surrounding this area, okay, if you work using the GPS instrument, so you can tie to the tree of this control station, okay, and then it will calculate on your position during you carry out the observation. Okay. Okay, wait. Okay, example. Okay, example, when you carry out the GPS, GPS, so you will have we call as a base and rover. Okay, so this one semester 4, semester 4 you will learn. But this one example I want to relate with the CRM. In order you want to establish the CRM, okay, so this is the first thing that surveyor will do. Okay, so the GPS, okay, equipment, okay, will be set up like this. Okay, example, you have a 2 point. Okay, so previous okay, so this one will be labeled as a base. Okay, and then another one will be labeled as a rover. Okay. Okay, so base and rover. Okay, and then when you carry out the GPS, okay, so it will have a connection to at least 4 satellite. Okay, at least 4 satellite. Okay, at least 4 satellite. Example, you have okay, later maybe you will see the image like this. Okay, you have 4 satellite. All these satellite, okay, will have a connection to this equipment. Okay. Okay, base as a non-point. Okay, so this one example non-point. Okay, and then this one unknown point. Okay, point yang you nak ketahui. Okay. Allah. Okay, point yang you nak ketahui unknown point. Okay, so previously when surveyor conduct, so this one they need to example they go to the site, okay, do the observation, and then they want to know the coordinate of this unknown point, okay, based on this known point. Okay, so the surveyor need to go to the office. Okay, they need to do the processing of the data. Okay, processing the coordinate, and then you will get the coordinate. Okay, so during that time, this method we call as a post processing. Okay, post processing. Okay, so but now, okay, we talk about the real time positioning. So meaning when you conduct the GPS equipment, this one, okay, and then you tie with the control point. Okay, control point example at Arau. Okay, then you can get the coordinate directly. Okay, coordinate directly. So that's why it called as a real-time positioning. Okay, no need like on the previous, you need to go to the office, you need to do the processing, and then from that you will get the data, and you will get the coordinate that you can use directly. Okay, so why I explain this one, because later, okay, you will use in order to set up the CRM, this one, cadastral referral map. Okay, so this one, the flow, okay. So this one, the flow, okay, as a summary, okay, from the old triangulation network, then go to the passive GPS network, okay, MRT48, go to the PMGSM 94, then go to the active GPS network, mass station, then next change to the active GNSS network, okay, we call as a MRTK network. Okay, so as at the private agency, license and surveyor Juruko Tanah Belesen. So basically Juruko Tanah Belesen, they will have an account, okay, in order to have the data, okay, the account that you can relate with the control station at the JUPEM. Okay, so that the license and surveyor need to subtract, okay, 1 year about 1,000. Okay, so in UITM we have an account. Okay, when student use the GPS, okay, they can tie with the MAATKNet station in order to get the real time data, real time positioning. Okay, so that account need to renew, okay, every year. Okay, okay, next okay, we go to the cadastral reference mark. Okay, so what is the cadastral reference mark? Cadastral reference mark is you can refer in page 27. Okay, page 27. So cadastral reference mark means a cadastral reference mark station based on GDM 1000 coordinate that updated for the data adjustment cadastral survey. Okay, so example here, okay, example here, if you see this here, you have a few lot here. Okay, if you have a few lot, and then you required to survey this land parcel, okay, PTD 1000. Okay, if you look on here, this land parcel already become as a lot. So there is a lot number 2000 and 2001. Okay, so others than this, you have a 2002 lot and 1998. Okay, if I'm not mistaken. Okay, from here you required to survey this lot. Okay, as a previous practice, you can use three boundary mark. Okay, example, you have a three boundary mark here. Okay, you have a three boundary mark here. Okay, okay, so you can use in order to start the survey. Okay, datum to start survey. Okay, so you can use three boundary mark, or you use two boundary mark, and then you carry out the solar observation. Okay, so from that, okay, once you use two boundary mark, one solar observation, then you can start your survey. You start your survey surrounding this lot, okay, and then you close back. Okay, so you close back. But now why you have introduced with the GNSS, okay, GPS technology. So that's why they have a new type of datum to start for survey. Okay, we call as a CRM. Okay, so in a survey department, so they will have their own team, okay, to establish the CRM point. Okay, example, they establish here, okay, one point, another point here. Okay, so these 2 points, okay, visible to each other. So example, you set up your total station here. Okay, you set up your total station here. Then another one here, you set up your prism reflector. Okay, so from here to point. Okay, then you start your survey. Okay, and then they will establish, okay, here at least 3 CRM point. Okay, another one here cross, okay, cross to the lot. Okay, cross to the lot. Okay, so this one visible to each other, and then another one cross to the lot. Okay, so this is in order to improve, okay, to improve the survey method. Okay, to start the survey. Okay, because on the previous difficulty, how you want to in order you want to set to define the 3 boundary mark. Okay, the 3 boundary mark, you need to check the angle. Okay, if this 3 boundary mark cannot be used, okay, so maybe only 2 boundary mark can be used. Okay, and then you have obstacle to observe the solar observation. Okay, so maybe you need to find another boundary mark here. So you have 3 boundary mark, you check this angle, okay, in order to use the 3 boundary mark. So with the new datum to start survey, CRM point. Okay, so that is what the surveyor can use in order to start the survey. Okay, without difficulty. Okay, so if you look to the reference textbook, okay, reference textbook, in order you want to set up the CRM point, okay, CRM point. So you can open page 28. They have a few criteria that need to be considered, okay, for establishment of CRM. The first one, cut-off angle at least 15 degrees surrounding CRM station. Okay, so this one cut-off angle means when you carry out the GPS. Okay, so the cut-off angle means here. Okay, so mana-mana data yang datang, signal yang datang 15 degree, okay, pada bahagian yang saya lukis ni, okay, so it will be removed. Okay, so this one noise data, okay, and then it's only focus on this angle, signal yang datang daripada kawasan sebelah atas. Okay, because if you take zero, you set zero, so you take any signal that okay can get for this GPS equipment, so it will consist with the noise, okay, with the error. Then second, the land surface surrounding CRM must be stable. Okay, so you find the area, okay, that area is flat area and stable area. Avoid things that can cause interference, okay, can influence, okay, influence to the data. Example, okay, you need to, in order to use a GPS, so it needs the clear area. Okay, so example, you not under the canopy. Okay, you far from the tree. Next, CRM mark must be established at a safe location. Okay, kawasan yang selamat. Okay, selamat dari segi kalau ada apa ni upgrading of a route, example. Okay, so it will not construct the CRM that already established. Then next, the location of the CRM point must far from the things which cause blocking the satellite wave. Okay, so example, if you have in a town area, you want to establish the CRM, so you need to far from the tall building, highest building. Okay, you must avoid. Okay, because it will influence to your data. Okay, so CRM as one of a datum that you will use in order to start your survey in cadastral, other than two boundary mark with one solar observation and three boundary mark. Check the angle. Okay, then we go to the type of boundary mark. Okay, so based on the regulation 25 CSR 5 2009 cadastral survey regulation, so there are a few. Okay, so there are a few type of boundary mark. Okay, so they have a few type of boundary mark are permitted, such as concrete stone, concrete pillar, granite stone, iron pipe, which follow the size as stated by the JUPAM, nail and iron nail with a concrete mark on stone, hole with arrow sign, and any marks that allowed by JUPAM. Okay, so example, the concrete stone. Okay, so the concrete stone is about 600 mm. Okay, and 75 mm for the width. Okay, and then they have a dawai besi. Okay, and then on top of it they have a tanda titik station. Okay, JUP. Okay, so on top of it, okay, it will have a nombor. Sometimes you will see the nombor. Okay, on top of the concrete stone. Okay, then this one concrete pillar. Okay, concrete pillar about 1,200 mm and 70 millimeter. Okay, for the width. Same thing, you have a dawai besi. Okay, and then tanda titik station on top. Okay, so this why they have a dawai besi, in order to make the concrete stone, concrete pillar, okay, can be maintained. Okay, can be maintained for a long time. Okay, if they have construction, okay, so at least it will okay can be maintained on the right place. Okay, next granite stone. Okay, so granite stone sometimes this will be used on the previous old time. Okay, and then this one some rural area you will find this granite stone. Okay, especially in the river area, kawasan berdekatan dengan sungai. Okay, then iron pipe. Okay, iron pipe. So you have 900 mm and 25 mm. Okay, so same thing. You will have on top of it with the point. Okay, point that you when you set up the instrument. So you need to make sure you use optical plummet, and then you ensure the equipment center to the tanda station. Okay, then you have a nail. Okay, so nail. Okay, so this is the specification. Okay, so this one, okay, the standard that have been provided by the JUPAM. Okay, and then the nail. Okay, and then spike. Okay, so this will be used at the new area. Example, the new housing area, the shop lot area. Okay, so you will see when you carry out the observation, field survey. Okay, field survey, field observation surrounding the new area of a shop lot. Okay, so you will see the spike. Okay, spike or nail. Okay, and then you have a mark on rock. Okay, so mark on rock. Okay, but so most of the boundary mark. Okay, so that will use have been used in UITM. Okay, so you will see as a BKL. Okay, batu konkrit lama. Okay, so this the boundary mark, okay, that you can see, okay, batu bernombor, granite stone, okay, and then batu konkrit lama, batu konkrit baru. Okay, so in UiTM basically you will see like this, okay, this boundary mark. Okay, so that in order we want to separate from one land parcel to another land parcel. Okay, so as for your field work, okay, for your field work, okay, so you need to mark the corner of the land parcel with the boundary mark, okay, because you want to create a new lot. Okay, you want to create a new lot, that's why you apply the first alienation. Okay, so anything you can follow, okay, in term of this one in stone, in stone, the it will provide in term of training. Okay, but you as a student, okay, I think you follow the class, okay, and then you follow during the field work. Okay, so you already have the reference book. Okay, inshallah you will more understand. Okay, what is the cadastral survey? Okay, wait. Okay, I want to discuss about the tutorial. Okay, because this tutorial also relate with the uh, our topic. Okay, our cadastral survey. Okay, so this is important. Okay, firstly, I want to know for group B. So group B with Dr. Khairil, Captain Khairil. Okay, what you have done, group B, for this week on your practical, close traverse. Have you finished? Okay. So how many stations that have you conduct? Only four. Okay. Okay. For my group, okay, group A, you need to conduct at least 5 stations, and then I think only one group that finish. Is it right? Group A.
Yes, sir.
Okay, only one group. Okay, but I think okay the data also not okay not can not close, okay, to the starting point. Okay, so maybe later, okay, you can share your data. Okay, so example here, okay, when you conduct the practical. I think I need to copy. Okay. So sorry. think I need to use mesh. This one. Okay, example example during you want to start survey you will record as a assume datum, example assume datum. Okay, and then you will write down at here. Okay, and then the value. Okay, so you write on this. Okay, under the mean column. Okay, next. Okay, so next you will write down from station number and to station number. Okay, so below of this you need to you write. Okay, sorry. Okay, so you write the description of the point. Okay, then continue here. You record the vertical angle. Vertical angle for the face left and slope distance. Okay, slope distance for the face left also. Then you need to write down the final distance, horizontal distance. Okay. Okay, so this one final distance. Okay, so for the distance here, okay, if you take the vertical angle, okay, so you need to use the SD, okay, slope distance. So this one only for the horizontal distance, HD. Okay. Okay, so this how you want to write down, okay, in your observation. Okay, so that's why I want all the student, okay, look. Okay, I think on the tutorial class or practical class before this I already show, but again I show again. Okay, so at least you know how to record 2 to 1. Okay, you will refer. Okay, you will set as your reference, and then 2 to 3 you will observe. Okay, so here what you need to fill up. So you fill up this value. Okay, so 189, 44, and 40. Okay, and then for the face right. Okay, if this one already more than 180, so this one, so you minus with 180, so you get the 90 degree. Okay, so this one you get 90 degree, 44, okay, 40. Okay, then from here 2 to 1. Okay, so 2 to 1 face left you already record the data, and then now you need to observe 2 to 3. Okay, you observe 2 to 3, and then you target to your reflector, and then you record the data. Okay, you record the horizontal data, and then automatic you write down from station number 2 to station number 3. Okay, to station number 3. Okay, from station number 2 to station number 3. Okay, and then for the vertical angle, you put H. Okay, because in cadastral, we only want the position. That's why we not record the vertical angle. Okay, then for the distance here, once we not record the vertical angle, so this one you record, you write down the horizontal distance. Okay, horizontal distance. Okay, so now you already finished. Okay, example, you have from 2 to 1. Okay, and then you have 2 to 3. Okay, 2 to 3. Sorry. Okay, so I follow the direction. Okay, 2 to 1, 189. Example, 2 to 1. Okay, so 2 to 1 in quadrant number 3. Okay, quadrant number 3. Okay, so 2 to 1, then observe 2 to 3. 2 to 3, face left 90 degrees. Okay, about like this. Okay, okay, station number 3. Okay, 2 to 1 you set, then 2 to 3 you observe. Okay, for the first line you need to record the data. Okay, vertical angle, slope distance, horizontal distance. Then 2 to 3 you observe here, horizontal angle, then 2 to 3, then you record the HD. Okay, 2 to 3. Okay, then finish for the face left, you turn back. Okay, you turn back to the face right. I don't know what happened to my tool. Okay. Okay, you turn back 2 to 1 as a face right. Okay, face right you need to set with the 9 degree 44 minute and 40 second. Okay, you set this value. Okay, then you observe. Okay, is it you have a data that you need to record for 2 to 1 face right? Yes, you have a vertical angle here, and then the slope distance here. Okay, that only. Horizontal distance only you based on the face left. Okay, once you already set, okay, the value 2 to 1, then you lose the clamp and then you target 2 to 3. You target 2 to 3, then you record the horizontal value here. Okay, in order you record this value, you need to check with the previous value. Okay, on the face left. So the tolerance within 20 seconds. Okay, 20 seconds. So if you look here, this one, 90, 36, 90 and 270. Okay, 36 and 35. Okay, why different almost 1 minute? Okay, but you check first the second. Okay, so this one 36:02 second. So this one 35 80 58 second. So meaning the different, what the different class here? Okay, 4 second. Okay, so meaning 4 second is within 20 second. So you can write. Okay, you can write. Or if you already write, please you check. Okay, because you not only have a few station, but you will have, okay, more station. Okay, maybe 10 station after this. Okay, so you need to imagine, if you want to make sure your travels close. Okay, so other than you temporary adjustment, you set up your equipment, you check optical plummet to your target of your station, then another things you need to check about your data, in your field book. Okay, once you already record the face right here, okay, then you need to record the horizontal distance face right. Okay, so now means 2 to 1, 2 to 3, you already finished. Okay, you already finished. So now from 3 to 2 and 3 to 2, observe 3 to 4. Okay, and okay, 3 to 2, we observe 3 to 4. Okay, 3 to 4. So 3 to 2, you will refer. Now 3 to 2, you will refer here. Okay, so in order you want to refer, so you need to calculate the mean first. Okay, mean bearing here. So if this data, so the mean will be as a, the mean will be as a 90 degrees, 3600. Is it right, class? This value for the mean, is it right?
Yes.
Okay, mana suara lain? Suara lain? Dengar suara yang sama ya?
Ada sir, ada.
Ada. Takut ni kan.
Ada sir, ada.
Ada sir.
Okay, right. Okay, so now you already have a mean bearing. Okay, mean bearing. Okay. Okay, then what you need to do? You need to cross. Okay, you need to cross here the degree. Sekejap Sorry murid-murid. Okay, so this one you cross, this one you cross. What you need to cross? You cross the degree. So this example here, this one 270. Okay, 270 here. This one 270, and then this one 90 degrees. Okay, then the minute and second you take from the mean here. Mean here you have 36 and 00. So you put here 36 and 00, 36, 00. Okay, then once you have this value, okay, so this value you will use 3 to 2 you target, and then you set the value. Okay, example face left 270 3600. So the value that you need to set. Okay, then you observe 3 to 4. Okay, for the face left. But before that, 3 to 2, is it you required to take the vertical angle slope distance or any distance that you need to record? No need, because 3 to 2, you will at this stage you will refer only, because the 3 to 2 data in terms of the horizontal distance you already have in this line. Okay, so this line represent 2 to 3, but same thing when you refer 3 to 2, the distance is same. Okay, only the bearing will be opposite direction, opposite value. Okay, so meaning 3 to 2 you just set. Okay, no need you need to record. Okay, during this stage. Okay, then you turn 3 to 4. Okay, then you record the value. Okay, face left, and 3 to 4, then H. Next, you write down the horizontal distance. Okay, face left. Next, okay, once you finish, 3 to 2 again, but using face right. Okay, using the face right, you need to set with the 90 degree 3600. Set, then loose clamp, target 3 to 4. Target 3 to 4, you get this value. Okay, so this value and this value is about 4 seconds different. Okay, so it's within the limit. Then you just proceed, calculate mean. Okay, then you cross the value. Then you will okay, so you will continue your observation. Okay, but in this case you will look. Okay, why this station refer to the same station 3 to 2 again, and then they have a 3 to 5. Okay, then below of this they have a 3 to 4. Okay, 3 to 4 observe 3 to 5. Okay, so this one later you will learn. Okay, so this one about the double independent check. Okay, double independent check, this one. Okay, so this one a radiation line. Okay, example 322. Okay, and then they have 215. Okay, they have radiation line to station 5. Okay, so if you look here, okay, so what you can do, you just continue to the next line here, 3 to 4, then you continue on this line. Okay, you continue on this line, 4 to 3 refer, and then 4 to 6 observe. Okay, then okay, you fill up. Okay, in the tutorial class you just fill up the calculate the mean. Okay, then proceed 6 to 4. Okay, you try to see 6 to 4. Okay, 6 to 1. Okay, 6 to 4, 6 to 1. Okay, 6 to 4, 6 to 1. Okay, so then this one again, this one radiation line. Okay, they have a 6 to 7, 6 to 7, so meaning 7 here, example. Then this one double independent check to check this hanging line, the radiation line. Okay, so you just continue to here. Okay, 1 to 6 refer, then 1 to 2 you close. Okay, so you can see now. Okay, you start from 2 to 1, then you close 1 to 2. Okay, so from here that you use the data in order to calculate the C correction. Okay, last semester you already learned, right, how to calculate the C correction. Class.
Yes, sir.
You have learned okay, garisan 1 ke 2 dibaca, kan? Itu sepatutnya dibaca. Hikaian, pembetulan, betul? Last semester ada ni.
Yes, sir.
Okay, so example, once you already close, you already close this one, the loop. Okay. Okay, so this one garisan 1 ke 2 dibaca. Kat mana yang you nak ambil? You akan ambil kat sini, betul? Dekat min dia. Class?
Yes, sir.
You all follow ni?
Follow.
Okay. Follow macam tidur je tu. Follow. Okay. Garisan 1 ke 2 diambil kat sini, betul tak?
Betul.
Saya salah.
Betul.
Okay, so you akan tulis dekat sini. Okay, sebab saya tengok ada yang salah, kan? Saya tengok daripada tutorial yang you buat tu, bila you hantar saya check, saya tengok. Okay, ada yang salah. Okay. Dia pergi ambil daripada tempat lain ataupun dia ambil kat sini, tak silap saya. Okay, kat sini directly dia terus tulis kat ini. Lepas tu sepatutnya dibaca. Should be read, you can take from here. Okay, daripada face right ni. Kalau kat sini 189 face left, right dia 94400 kan. Okay, 94440. So dekat sini sepatutnya dibaca 945 dengan 35. Okay, so tikaian dia berapa tikaian dia ni you dapat? Berapa kelas you dapat? This one minus this one 55 kan?
Ya, kejap sir, kejap.
55 second. Betul tak? 5996.
Betul, sir.
Okay. Okay, 55. In how many station? Okay, bila dia kata in how many station ni, station yang terlibat untuk loop traverse. Loop traverse tu adalah this one lah. 1, 2, 3, 4, 5 dan 5 nombor 6 ni. 5. Okay, so 5 dan 7 ni tak terlibat sebab dia adalah garisan tergantung ataupun kita panggil sebagai hanging line ataupun kita panggil sebagai radiation line. Okay, so bila you buat traverse nanti you akan tahu. Okay, dia akan ada garisan yang you pick up batu dan sebagainya, dia tergantung. So this one you tak akan guna pakai untuk dalam pengiraan pembetulan C. Okay, so yang you kira adalah loop yang dia akan create sebagai loop. Okay, so kat sini ada 5. Okay, so you kena tulis lah 2, 3, 4, 6 and 1. Okay, and then so you 55 second divide by 5. Okay, so you will get the negative 11 second. Okay, okay, understand class?
Boleh, sir.
Okay,
Yes, sir.
negative 11 second. So you apply at this one. Okay, so apa yang you tulis bawah yang mean bearing tadi tu. Okay, sekejap saya nak tulis ni dia tangguh pula. Okay, C negative 11 second. Okay, next line yang okay, line yang pertama. Okay, 2 ke 3 kan. Okay, so kat sini adalah C1. This one C2, C3, C4, last kali adalah C5. Okay, so C1 sini, C2 dekat sini. Okay, so dia akan C2 akan jadi negatif 22. Okay, negatif 22 second. C3 kat sini dia akan jadi negatif 33. C4 dekat sini. C4 kat sini negatif 44 dan last kali C5 negatif 55. So bila you calculate balik, okay, mean bearing sini 9 45 35 tolak dengan yang ni 9 45 35 you minus with 55 second. So you will get this value. Betul? Betul tak kelas? So dari situ, okay, you akan dapat 9. Ganggu lah benda ni. Sekejap. 9, 44 and 40. Okay, so this one, okay, bacaan 1 ke 2 kan, 1 ke 2 adalah 9, 44, 40. Okay, okay, so bila kita tengok kat sini 2 ke 1 dia adalah 189, 44, 40. Okay, betul lah. Okay, cuma kat sini bila dia ada this one ada melibatkan dengan cerapan matahari. So selepas ni kita akan ada pembetulan M. Okay, so pembetulan M kemudian dulu. Kita tak payah masuk lagi. So you tak boleh calculate lagi final bearing. Okay, actually you cannot calculate the final bearing because in this form you will have another value. Okay, M correction. Okay, M correction. M correction ni you akan apply pada semua line sebab dia akan it will correct your orientation. Okay, your orientation of a traverse network. Okay, so that is what the important that you need to understand, and then you try to relate with what you already practice in your practical. Okay, so at least you understand. Okay, bila you already done with 5 station, and then how you want to calculate the C correction, and then which line that you want to apply the C correction. Okay, so that is important, because after this you will have another correction we call as a M correction. Okay, for the horizontal distance, okay, you just average here and then you write down here. Okay, average this value, you write down here. Okay. Okay, any problem with this, how you want to record dan sebagainya? Because this one you will apply during your practical. Okay, during the tutorial I give the exercise and then I want you all to do. Okay, so that I will evaluate, I will see whether you understand or not. Okay, and then during this class I discuss, and then if you don't understand you can ask. Okay, any problem?
No, sir.
No, sir.
No, sir.
No,
Okay.
sir.
All right, if no problem. Okay. If no problem. Okay, you can see this my screen, global mapper.
Yes.
Yes, sir.
Okay, so this
Yes,
one,
sir.
what you have, you already watched the video. Okay, example, you prepare land parcel. Okay, land parcel that you want to carry out the survey, and then you required to set. Okay, you required to set at the configuration. Okay, so this one you go to the configure, and then we go to the projection. Okay, projection. So this one, the what you have learned, and what you have learned in the chapter number 2, and just now. Okay, you learn about the. Okay, so here projection. Okay, for our purpose, example, Cassini Malaysia or Cassini Solna. Okay, and then your datum. Okay, Cassini Solna, example, you perform the old datum. Okay, MRT. MRT. Okay, example, datum GDM 2000. Okay, GDM 2000. Okay, so other than that, if you use for the engineering, okay, so you need to set as a RS, okay, RSO, RSO, okay, RSO. Okay, so here they have the attribute okay, the information, okay, regarding to the you choose for the datum. Okay, you choose for the datum. Okay, example here Cassini. Okay, so then this one you Cassini Malaysia, then you choose Kedah Perlis. Okay, GDM 2000, then you apply. Bila you ada data. Okay, so this is important to all of you. Okay, you set the datum and projection, the zone. Okay, then you apply to your data. Okay, example, you have a data, then file, you need to export your data. You export for the cadastral, you not have an image, you have a point, line, and polygon. So meaning export the vector data format. Okay, vector format. Okay, so it required. Okay, first load vector data, line, point, area, features data. Okay, so you kena masukkan the land parcel, land parcel that you already sketch in AutoCAD, DWG, and then you import, file open. Okay, then you go to configure, then you apply what you have learned. okay, from our class today. Okay. Okay, from that, so this is one of the software, okay, that can relate. And then you have the software in order to convert the coordinate, okay, to convert the coordinate from Cassini old to Cassini new, example, okay. So from old datum to a new datum GDM 2000, okay. So that we call as a GDTS software. Okay, class. So any question right now? Okay. So I